Okay, good afternoon, everyone. Thank you for joining us for the Beyond the Limits of AI, exploring new possibilities through multimodal and real-world understanding. My name is Yoshihiro Kawahara, a professor at the University of Tokyo, and I'm honored to serve your moderator today. So AI has made remarkable progress, as you already know, especially in the domain of large language models. But AI is not just about the text. When it is combined with other data, including videos, voices, and robotics, probably we see a lot more future opportunities. So we invited distinguished panelists from all industries across all disciplines, and I want to discuss what is limitation of the current technology and what's even possible with the combination of other modalities. So first, let me briefly introduce our distinguished panelists. The Professor Fujii Teruo he's the president of the University of Tokyo, and he's a leader in microfluidics research and a strong advocate for diversity. And second speaker.
Hey. Thank you so much.
And the second speaker is Marc Pollefeys. He's a professor at AIHD Zürich, and he's also a director of Microsoft Spatial AI Zürich Lab. And he's known for his pioneering work in 3D reconstruction from photographs. And the third speaker is Bolor-Erdene Battsengel. She's a founder and CEO of AI Academy Asia. And she led Mongolia's in-Mongolia digital initiative, and she founded Girls Code NGO to promote digital inclusion. And the fourth speaker is Dr. Shinpei Kato. He's founder and CEO of Teruo, and co-founder and chairman of Autoware Foundation. And he created the first open source self-driving software named Autoware, and he's uniting a global community. And the final speaker is Professor Alivisatos. He's a president of the University of Chicago, and he's very famous for a nanoscale pioneer and well known for advancing colloidal nanocrystal into practical use. Okay, so let's move on to the discussions. And this panel session consists of mainly three parts. And the first part is about the sharing the current potential and the limitations of AI. And we'll start by looking at what AI can do now, where it may still fall short, and we want to share how it could evolve. And first, because we have two computer scientists in this panel, so I want to ask the perspectives from computer science part first. So Marc, I want to ask about the limitation of the language models. As I mentioned earlier, the language models are based on text, but it's going to be combined with multimodal data, and especially from the expert of the computer vision, what do you foresee from now?
Well, so it's been quite amazing to see what has happened in the last few years. We've seen essentially AI start to really make progress, I think around 2012, so more than a decade ago, by combining computational power, data, and then deep learning algorithms on images and on text. Text has really taken off, images also, but there were still many limitations. I think text really from 2 years ago, we've seen text really completely take off. This has been quite interesting. There's a lot of things that you can do with text. It's really the way that we communicate as we do now, right? So a lot of our, what's interesting about text is that it's already at a semantic level. So the tokens or the entities or so, the words are essentially already have semantic meaning and attached to that. And so there's also a lot of data around. What's been really interesting is to see that by having some tasks that are to complete, to learn, to essentially have these machine learning methods learn to fill the gaps, to predict the next word, or to fill some of the gaps in the text, the algorithms were able to learn how to really do a lot of things with text. So you could do many other tasks also with this. And so it's been really impressive. Now, we also have to see, and so essentially, there's a lot of application in that space. For example, at Microsoft, the company has been very lucky in a sense that word processing, Teams communication, many of the software of the things that we do, even PowerPoint is images with bullet points, text, and so on. All of that directly benefits from being able to manipulate and synthesize or make a short version of a text or reformulate it in a different way and so on. All of this becomes possible now. Those things work really well. However, there's still limitation. AI, until today, mostly can only reproduce what you feed it, and more or less literally. There are techniques that allow you to, a little bit do things that you haven't literally seen before, but it's still very limited. For example, in multimodal and images, the so-called convolutional neural networks allow to train to recognize things from images. You don't have to show, for example, let's say cats or so, which is a typical example, cats and dogs and stuff like that people train algorithms on. You don't have to show the cat in every possible cat in every possible position in the image. The algorithms have baked in the capability to essentially recognize the thing independently of where it is in the space, in the image, and so on. So you don't have to show it everything. However, at many levels, at a deeper level, it can only really reproduce what you show it, up to sometimes this possibility to generalize over where it is or this or that. But in most cases, semantically and so on, it doesn't really generalize still today beyond what it sees. Also, still most of the AI today, even if it's multimodal, it's still mostly text first. So most of the models are trained on text and then extended to bring in images through captions, images with captions, and so on. But they're missing things that are non-verbal. Elements that are non-verbal are often not present and not captured in the text. So this is going to change, but we might discuss it later also in self-driving in other places. If you haven't seen a situation, it's a little bit random what will happen in terms of answer. So AI today is still trained by showing it pairs of input and output. This can also be, from the data itself or so. You show it the words, and then you have to predict the next word, but you already know the next word, and you just try to learn to predict the correct word that you already know should be there. And it just keeps reproducing those things. But if you have a completely new situation, it would just essentially generate a random answer. It doesn't have, common sense or so. It's still not captured. It's mostly interpolation and not extrapolation.
So basically, the recent AI understand the images just because captions are everywhere available on the internet.
For a big part. I mean, there's more to it and so on, but simplified. The link to what concepts are in there and so on is through captions and through things like that. So you need lots of data, tons of data. You can complement that with synthetic data potentially, so you can generate images. If you have good graphics, you can generate a lot of examples, and then you can essentially from those kind of, also the nice thing about synthetics is you know exactly the answer because you render a cat, for example, then you know it's a cat that's being rendered, and so you know that you should see a cat over there in the image because that's where you placed it. But yes.
Okay, thank you for sharing the expert's view. And I want to ask another question to Shinpei. You pioneered the open source software for self-driving car, and the self-driving car needs to make a lot of layered decisions for every scene, almost every second. And so could you share us one of the latest progress in, for example, simulations or understanding the real world?
Yeah, so self-driving is, I think, one of the good application of AI that was spin out from academia, because it started in the government project in academia. Now, the first generation of self-driving used AI to recognize the environments, including objects and so on. Now, the second generation of self-driving uses AI to generate the actions. So it's quite different between recognizing object or generating action. So in case of driving, recognizing means that object detection, but generating actions is more like a controlling steering, axle, brake directly from the AI. So that's a huge, significant leap thanks to the emerging generative AI technologies. That being said, the best performance, I would say, the AI today exceeds the human's capabilities, but actually I had discussion with Marc before the session, but if you consider the worst case performance, you still need a lot of challenges using AI because human capabilities are still in some sense predictable, but worst case AI performance is not predictable. So if you think about reliability or safety, always you have to think about the worst case, as at least today's perception in a society. So the challenges would be how to deal with the worst case performance if you want to leverage AI for kind of safety critical applications such as self-driving.
Yeah, for physical application like self-driving car, you cannot make any mistake to keep everyone safe, right? So it might be other criteria may be necessary for the progress of the generative AI.
Yeah, and many other things like so it's a power eater self-driving. So like GPUs today, we also have to consider how we can make it carbon neutral. But yes, all in all, we first need to consider the worst case performance because safety is the first priority. And there will be so many other challenges like power consumption once we address the safety worst case issues.
Okay. Thank you so much. So next, I want to move on to the AI's impact across other disciplines. And Paul, I want to ask about the impact for your area, especially in chemics. So everyone knows about AlphaFold, success of AlphaFold.
Yes.
And it must have left a strong impression for the whole community. Do you see more revolutionary moments like that on the horizon? Or could you give any impression or
Yeah. Thank you. Well, let me say a little bit about AlphaFold, and then we'll, the lessons from it, and to agree with these two examples of how it's moving along. So first of all, 2 years ago when the ChatGPT moment had, probably most of you remember the astonishment you felt at that moment. So I think for people in kind of my neck of the woods in the chemistry, biology, interface kind of world, that moment was when AlphaFold came out. I mean, it was absolutely stunning. Here is the proteins, of course, represent a code, the sequence of amino acids, which are so fundamental for chemistry and for life because they take a code and translate it into a physical arrangement of how it folds, which is how biology takes the information and acts on the world. So it's right at the center of this question of how information goes into action in the world of chemistry and life. And that problem, the protein folding problem, was studied for 50 years by physicists and chemists and biologists and mathematicians, and no one could solve the protein folding problem. And in this case, what's very special about it was the quality of information. There had been 30 years of determined work to develop the protein sequences and to develop the protein structures through the synchrotrons and other places. So there was a determined effort by the science community to have the best data set possible. And within a very short time, so John Jumper, one of the laureates of the Nobel Prize this year, was a 2017 graduate of our PhD program. He got the Nobel Prize, within 6 years of graduating because the data was there. It was incredible. And then the power of DeepMind. So, it's an example of kind of ideas at universities and in these companies and an incredible data set. They all came together. They solved a 50-year problem, which will have untold consequences for human health. And the lessons that I take from it are that to make the deepest progress in science, there'll be many, many, many examples where careful work to create a powerful data set will allow problems that previously had been completely unsolvable to suddenly be solved. And so this is an unbelievable moment in science for the opportunities that exist there across many fields.
So do you think it gave an impact for the chemist?
Oh my gosh, it's a huge one, but it also teaches many lessons, which is these tools are immensely powerful because they see levels of correlation of information on scales that human beings can't normally do, and they solve problems that are hard to solve by other means. But they require very good data sets. So there are lessons for chemistry, for material science, for nanoscience, for astronomy, and so on, that will all have to do with how we prepare very high quality data sets and then create communities to use those with the best AI tools.
Thank you so much.
Yeah.
So, Teruo, I want at the University of Tokyo, you emphasize the interdisciplinary approaches.
Yeah.
And so across the engineering, the life sciences, and also other disciplines. Can you share some other unique example that?
Yeah, right. So that, from this AlphaFold example, so we could see some, changes in the sort of disciplinary knowledge itself. And the one example is from one of our institutes. Is the so we have a Kavli Institute for the physics and mathematics of the universe, and then they are also trying to find out the kind of evolution, the way the universe is evolving, and then they are doing a kind of massive calculation of the development of the universe itself, and then with supercomputing facilities, but then it will take time, right? As you know, like a week or a couple of weeks, and then. But then if you do that with machine learning, then it will take only maybe several minutes to get one data set. So that if you calculate all these different different conditions of the parameters, then you could get a certain numbers which could be observable by the, for example, observatory at the on the summit of Mauna Kea or whatever. Then so they could compare all these things together. Then that is showing some sort of a new physics, appearance of a new physics, so that like this way you could basically accelerate the discovery by introducing this kind of machine learning technology into physics research. So like this way, what I wanted to emphasize is the way we could, for example, learn or think about disciplinary knowledge is changing somehow.
So I believe that some of the invention that happened in the AI area is also from the statistical physics and so on. So I think the interdisciplinary work will enhance the future improvement a lot more. So I want to ask Bolor about the impact to the society. And you have seen how digital service can transform in rural communities in Mongolia. And also, when implementing AI-based solutions, how do local context, cultural norms, or infrastructure limits shape your strategy? I want you to share some experience and thoughts about based on your experience.
Thank you. So I'm learning a lot on the invention and creation side of AI. I would like to share more practical AI inclusion side of my experience. So as we speak today in very nice setting of Davos, 2.2 billion people are not connected to the internet, which is a big number. And I worked as a vice minister of digital development back in Mongolia, where we started e-Mongolia project. So as you probably, some of you know, Mongolia is a big country, sandwiched between big in terms of landscape, very small in terms of population, which is 3.5 million, but we have one of the last nomadic communities. So throughout this big landscape, Mongolians are sparsely populated. We are very much sandwiched between Russia and China. And we have 80 million livestock for 3 million people. So you can imagine the dietary plans. So for us, it would be so easy for people who live in the city to get a government service, but it would be so hard to get a government service for people who live in the nomadic community. I come from herder community. My parents, I still own 300 ships. If you're in Mongolia, I'm happy to give you one. I think I can cover the room. Yes. And yeah, so I wanted to create something that's accessible to all citizens in Mongolia. And so far, almost 95% of the population can get every single government service online on the Mongolia platform. But also one of the things we wanted to ensure is that the data power is with the citizen, meaning that people can give consents of or monitor or control their own data. So let's say a government employee is checking my data, I get notified on who's checking my data for what purposes. So that's kind of our way of giving control over data to citizens. And from there on, we ended up creating a program called Girls Coding, which we bring girls from nomadic communities, poor communities, and teach them coding for the period of 2.5 months. And every girl has 12 hours of class, including Saturdays, Sundays for homework, quite intense. That's the way I used to learn back in school, so I thought I should torture somebody like that. But the impact has been amazing in the sense that we have girls who went on to Harvard, MIT, Stanford, very prestigious university, coming from poor family in the countryside who did not have access to internet. So this is very small example of inclusion in the sense if we can give people access to equal education, if we can give them iPhones or smart tools, it can create enormous impact. And so far we have only 120 girls, but a lot of them went on having startups. One girl created an app for security reasons whenever, they are teenagers, so whenever they feel emo or sad, they can send notification to their friends or family, which ended up being sold to one of the bigger companies. So we have seen amazing impact, but it has been very much limited. So back then we were talking about digital inclusion, which we haven't tackled entirely. Still, a lot of people are having no digital literacy skills or no smartphones or no access to internet. But then we, thanks to this gentleman, we have AI, and now we have to tackle AI inclusion problem. So. But one thing we're happy about is that we can actually use AI for customized education for people, let's say, from the forest in Peru to nomads in Mongolia to every single community. We can deliver them customized AI-based education tools. And that I am very much optimistic for, and that we can collectively, if we work together, we can really solve this problem. And for that purpose, we created AI Academy Asia. We're helping companies, schools, even government organizations to reskill and upskill in terms of AI. A lot of people do have the fear of losing their jobs to AI. So we're trying to work with people on improving themselves in terms of using AI for their own benefits, not being used for AI. So that has been our experience.
Thank you for sharing your experiences. So I want to move on to the topic 2, which is about the roles of academia and the industry, because some of the speakers shared the data is important. And also, it's very expensive to use the GPU computational resources because it requires massive amount of data resources. So some of the research topic is no longer able to perform within the academic society. So the working with industry is kind of inevitable trend. And on some of the groups are pretty good working at coordinating with the academia and the industry. For example, Marc has a dual position of the university and also industry research lab. So do you have any opinion on how the collaboration between academia and industry should happen to overcome what kind of limits AI will encounter from now. Does anybody have any question, any thought? Yes.
So I can say something. So I think they're actually quite complementary in many ways. What we see is now AI, once there is a good solution, then industry is very good at scaling it up, at getting the resources to kind of really move it forward and essentially productize it and bring it out and make it available to people, at least in a limited way, but still make it more broadly available. I think academia, in a sense, is now left behind in that they cannot compete in training as big models and so on. However, that's sometimes a good thing, because I think we, as I was indicating earlier, we're still really not at the end of figuring out AI. There are still, we would really like to bring in common sense, to bring in things that, when people do things, we are, also if you look at the most advanced models now, they cost a gigantic amount of energy just to, even for inference, not only for training, it's huge, but even for inference, inference meaning as when you use the model and you just want to recognize, people when they speak, understand them, and then respond to them, and things like this. All of this requires lots of energy today. Much, 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 much more than our own brain requires. So I think, in a sense, on the AI technology, we're still not doing things quite right. There's still clearly, proof existence. It is possible to do it with a lot less power and do it a lot better. In the sense, a lot better of being able to train from a lot fewer examples. ChatGPT and all of those models, they're trained on data that, we would need millions of lifetimes to be able to read everything that those models have read and have been trained on. Okay? So they're ridiculously inefficient in how they process information and what they cope with. So for that, I think there is tons of opportunity for academia to actually, figure things out and find better models. Someone in our field, for example, Björn Oemel, who, with his group at the university in Munich, invented diffusion. Partially, he was indicating because he couldn't have the resources that the big industry labs had. And so he was trying to be smarter and find other ways to do it that would require much less data, much less resources to be able to train. And so he invented this process of diffusion, which is you train from you can very easily take a good image and make it noisy. And then he trained a model to essentially invert that process. Given a noisy image, get back to the clean image. And then it turned out you could start that all from a random image and go all the way back to kind of generating, new images, back to real images and so on. So that's an example of academia actually, because of having less resources, having to find other ways to do things better. And I think there's plenty of opportunities there.
That makes sense. Yes.
So maybe I'd like to, that's perfect. I agree completely with what you said. Let me give 3 examples of problems which show the spectrum of things. So let's take, we know, to give you a specific instance where this kind of industry-academia partnership is working at our campus, we know that there are these drug-resistant bacteria. If you're in the hospital, you have a real chance of getting bacterial infection that can't be treated. So we have, for example, faculty who are studying vastly microbial communities. And if you look at a microbial community, the microbes are all, sometimes they're cooperating to help each other, but sometimes they're trying to kill each other. They're in war. And actually, if you take a large microbial community and analyze it, you can start to figure out from that the whole evolutionary history of how microbes have had wars with each other. That's too big of a problem computationally to be handled fully inside the university. So we have an example of a partnership like that. So that's one example. But now 2 others that fit a little bit. So we have faculty who are really trying in our Institute for Climate and Sustainable Growth to help farmers in places in the world where the agricultural production is susceptible to droughts and other problems. And you may get great climate prediction here in Europe or in the United States, but those people don't get it. So that's, no industry is going to do that. That has to be done by the academia. And one other example, we've seen so that's an example. We can do things together. There are things that we'll work on that the industry won't. But then there are areas where there are problems with industry, and I'll just give one quick example. We have today many practicing artists who are losing their livelihood because their data, their images, let's just take images as an example. It could be music, it could be lots of things. Their images have been folded into AI scarfing up all the data. And now they can say, I would like, please produce for me an image in the likeness of this current painter who's out there in the world. And suddenly that painter can't sell their own work anymore because... So we have a faculty member who is rather ingeniously teaching artists how to put things into their images which are not easily recognized by the eye, but which kind of mess up the algorithms that try to take up. So it's a kind of copyright protection for artists because they're trying to fix a problem that comes from industry basically having scarfed up everybody's data without asking for permission. So it covers the range. We can do things together. We can do problems they're not going to do. We can try to help fix problems that frankly industry creates.
Professor Fujii.
So then one role that I can also emphasize as a university is a kind of we are quite a neutral entity in a way. If we, for example, think about the apply to as a next application of AI, it could be like a manufacturing thing and then robotics but then we will need to collect all these data on site, hopefully on the manufacturing side. But then, so if you go, very specific to the special one specific company, then it will, make a kind of, we cannot make a kind of foundation of the whole thing. So that if we really want to go over to this application, then we will need to have a kind of diverse, source of data and high quality data. But it's not so easy for individual entity or a commercial entity to do that. So that if we could, for example, organize a sort of consortium of companies or industries, then so that we could basically collect all these data to be able to make a kind of set up a kind of foundation for the very strong application or physical application of the AI in the next generations.
Thank you very much. Professor Fujii just mentioned neutrality, and equity is also important for AI, and definitely university will be can take this role for whole society. And actually, this is related to the final topic about the social inclusion. So industry and academia work together, but if it is just sponsored by the industry, probably this is only for the people who are willing to pay. But as Bolor has mentioned, social inclusion, the taking advantage of the science discovery should be shared for the whole community in the world. So what do you think is necessary, and what kind of suggestion do you want to plan to make for the social inclusion, bridging the digital divide, and even the rethinking the role of education? So anyone can, you can start.
Thank you. So I think on the social media part, few years back when the social media was having all the hype, one of the things that went wrong was lack of collaboration, and you see a lot of problems that are created by social media, a lot of harassment, abuse, cyber attacks, leading to violence, leading to, especially for teenagers, security issues, suicide, etc., etc. And one of the things I was very much concerned was how ignorant the corporations were in terms of these issues. So Meta, for example, did not have any representative in Myanmar until the war went on to the level that it couldn't be saved at that very moment. So now on the social inclusion side, I think one of the things that we have to ensure is very tight, very close collaboration in between academia, governments, all these international tech companies who are making money off of this. and international organizations. I think ITU, UN, all World Bank, whatever, all the international organizations should really implement a lot of projects in this area along with local partners. But I cannot emphasize enough the role of companies. And a lot of companies, because they're private companies, they do not invest into communities that they don't make money from. So this is something that now that in terms of technology, the world is becoming flat and we're interconnected. So maybe this is something that we need to look back and try not to repeat with the transformation of AI.
So Shinpei.
Okay, yeah. So this Davos 2025, so we have the theme that the collaboration for the intelligent age. And one of the collaboration that we can consider, it's academia and industry. So sharing problems is most important thing to start with, because if the problem is shared, then they work together. But this doesn't happen often because academia has a different problem and industry has a different problem. So I think that we can design incentives to both sides, even though they, solving a different problem, but solving one problem should contribute to solving another problem. So that's an incentive. If somebody coordinating academia, industry can design incentives in a collaboration, then I think, including social inclusion, I think we can further step forward with the collaboration.
Yeah, this is a brilliant idea, I guess. And also, data is a key for AI and defining an important problem. By defining the big problem, probably it's easier to get the shared data together and solve the same problem from people from everywhere. Yeah.
So I believe, this equitable access to all this AI, and especially for the individual, the learning for individual should be, taken care of by AI. I hope the AI, that is what AI should be, and then for that, so for example, for university can take maybe two major points. So one is to come up with the tools, maybe in collaboration with the industry. But then another one is, so we need to share the idea of this, social value of this equitable access, also accessibility to AI and digital services. And that is more like, now it's almost like a kind of the same level of issue as of the, for example, as the climate change or whatever. We need to push that way in collaboration with, not only in academia, but also with the industry.
Maybe I can just say a word about the question. You appended at the end the option to answer a question about education. So if I can, I'll just add something onto that. So we have to think, these powerful tools are changing the way people think in so many ways. So here, our job as universities is to think about, what does it mean to be educated? What is that all about? And for us, a lot of thought has gone into that over more than a century. And the way in which we educate our undergraduates is to say, we would like our people to learn to think like a humanist, like a social scientist, like a scientist, a physical or a biological scientist, probably need to know some math. Maybe you should be good at studying a civilization or two. If you can do all those things, maybe you have enough tools to kind of look at the world and come up with good ways of thinking. And I think today, with what's happening, it would be fair to say we would also like that person to understand what it's like to think computationally, because that's a way of thinking about the world. You think of how to organize information and how to create algorithms. They don't necessarily have to be able to write code. They don't necessarily have to be able to, but they have to at least be able to understand how people think computationally, because these tools are becoming so powerful. They pervade our world. And so I think in a few years we're going to see how students are educated will look very different than it does today, and I think that's kind of exciting.
Marc?
Two smaller points related to the earlier question. One is I think the progress we've seen in AI, the rapid progress for a big part has been because it has become the default in the AI community, computer vision, NLP, and all of the machine learning and so on. It has become the default to share code, to share results, and to let people essentially build. And it's also creating problems for the community to review all of the work that's happening and so on, because things have really accelerated. But a big part comes from that. In my group, for example, we systematically, almost everything we do, we put it open source. We let other people build on top of it, modify it, even let companies use it. That actually makes that a lot of things are happening much faster now. So partially there's already that, and that means also that, there will be lots of opportunities to build on top of that, not only for the companies, but also other organizations. One example of that, I think, and an opportunity also for inclusion and so on, is there are, even in Switzerland, there are small languages that are struggling to stay around because of the dominance of social networks and others that actually bring English and other kind of things, but a lot of pressure, people not learning the language anymore and so on. In Switzerland here, the fourth language is Romansh, and that's one that is struggling to be at the same level as the other languages. I think with all the tools, with all the capabilities that are done now, there is the opportunity to actually help in education to have people be able to learn without necessarily having to have all the structure in place. You can actually save those languages. You can build models. Now, of course, the prerequisite for that is to collect enough data, good data, and so on. But this is something that now I think we're at a point where this can be put in the hands of those communities to actually collect and curate data sets. Similar as was done in Silo. So if you get kind of the right data, if you get incentives to save the language by actually also building AI that can teach it further, that can somehow evolve it, I think there's great opportunities for teaching people in that space. Lots of things that are going to come in the next few years, I think.
Thank you.
Yeah, just a small one.
Okay.
So AI can also fill in the gap in the skills, right? Today, you don't write a program. You can just use AI to create a program which can actually, standardize the education level. So any people basically can also write a new or contribute to the AI generation, which can also change the way of education. That is another way that I can think.
Yeah, I hope to add a lot more episode on that topic, but I want to make this opportunity as interactive as possible. So I think I want to make room for one question. Do you? Yeah, yes, please. Yeah. So probably, yeah.
I can briefly answer to the question. I think there are twofold. One is creating a data set is open challenge. You're right. We have to create not just large scale, but high quality data set, which is very challenging even for the text. But now we're going to be multimodal. You need more types of data like 3D models, maps, locations, and so on, which how you can assure the quality of data. It's definitely open challenge. That's why there are many other kind of research projects or companies which try to create a high, not only large scale, but also high quality data set. So the first answer is open challenge. But the second answer is that to develop the model architecture more redundant, so that even though you input a failure data set, but you can design the model architecture so that it can also defend from the failure data set. That's also part of the cutting edge research project. I would say there are many other practical solutions, but in theory, I think they are twofold.
Yeah, in my opinion, the data must be very clean, but in a sense, LLM succeeded in using dirty data because the web data on the web is very dirty, basically. But they take advantage of self-supervised learning and just simplify the problem and used massive computational amount of resources. And that's one thing. The another thing is feedback by human feedback and reinforcement learning by feedback. So it allows AI to give multiple answers and choose the most likely one. So so in other sense, that they overcame the problem by changing the architecture.
Should there be a global framework in terms of some specific areas like healthcare or defense, where there can be catastrophic problems, right? In terms if the data sets are not in the most qualitative format. So should there be a global framework in terms how this should be utilized?
Yep.
Yeah, for healthcare data, so there are some certain, there are a couple of, widely used format. Yeah, for the healthcare data.
For defense, I'm curious what you mean because I'm very worried there.
Yeah, so there are a bunch of projects on defense with AI, and that's why I was curious in terms of.
I think I can receive one more questions. Okay.
I really enjoyed listening. Okay. I hope it works now. It was such a pleasure to witness that data is the cornerstone of the discussions here. But I have a direct question for Professor Marc. Mostly taking from the observation and the statement from Ilya in Europe. Do you believe that the era of LLM scaling is over? And if that is the case, because we're witnessing that computer scaling data is not. And if you believe so, do you think that it's going to be more of a trend like in nature? So when trends basically plateau, then nature goes and finds other species?
Well, so I think indeed the current, and beyond LLM, the current kind of generation of AI algorithms is kind of, so there's two things. One is they're clearly starting to show their limits, that they cannot, as I was saying, they mostly interpolate and they can't really extrapolate or kind of generalize. On the one hand, on the other hand, we've kind of used all the data there is, in a sense, at least at some level. Now it depends, we could be recording all people's conversations, potentially there might be other places to find data, but it's not, certainly curated data is kind of most in the general, let's say, text domain and so on. It's different, I think, in healthcare, for example, where there's, I think, data really needs to be brought together and systematically captured. And I think opportunities are huge there and immense. But let's say in the more general things, the data is kind of saturated, and the current algorithms are also in a sense saturating. So I think what I expect to see is kind of essentially, like next generation algorithms. So I think that's exactly where universities actually are coming in. That there is still other things to be found to move algorithms forward.
Thank you.
Test time compute. Have you? So this is what the O1 models from OpenAI actually use. And my question actually to the panel is, with test time compute and the increased number of tokens per second we can do from multimodal models and others, what sorts of impacts do you expect to see without the data that is missing from this? Are we going to see the kind of exponential that OpenAI is predicting? Or is this something that the academics in the room have opinions on?
I mean, I don't know the details of what exactly they've implemented and so on, but I think as far as I understand, this comes with huge amounts of extra energy because they are pursuing lots of things in parallel, and then try to, using reinforcement or other things, try to figure out what path to, what to select and how to do this. So that doesn't seem to be like the way forward. We need to be able to get kind of AI to much more energy efficient, also to make it available to everyone. If we need kilowatts of power for every generation of an answer, and so forget it. So I think there's more to be found. I think it is saturating. If you need 7 trillion to build the next supercomputer to do all of this, etc., then we're not going to get there.
photonic computing inference may be one of those.
Yeah, sure. And maybe some quantum also, yes, of course.
Well,
Okay, one question.
Yeah, still for Professor Pollefeys. My name is Fujii. You made a statement being very sure that it's just next token prediction. I mean, described the model. With such large modules with so many weights, could you say some more why you're so sure that there's no emergence of something else going on?
No, like I can't really say it, but when you observe what those models like, like if so in generative AI you can generate lots of plausible answers or things that make sense somehow. When there's a lot of problems where also, for example, like where AI can outperform humans in places where there's enough data to do that or so. But if you just, I work in computer vision, if you just go with a camera around and you have to explain what's going on and so on some data sets, ImageNet and so on, which started all of this in 2012 or so, sure, you get superhuman performance already for quite a while. If you actually work with your camera down the street and you ask it to understand what's going on, it's nowhere near human level performance. So I think there's still clearly things that are missing. This is also why, Tesla and others are just not managing to get their cars to drive. Unsupervised full self-driving is the new terminology. If those things really worked, if there was really something beyond that really grasps, like general intelligence essentially, it would actually be able to solve those problems.
Okay, we are running out of the time, and I want to thank all the speakers and also audiences for giving exciting questions and also important questions. And so on behalf of everyone here, I extend my gratitude to everyone. And I hope today's session was very meaningful to you all, and it resulted in the future collaborations and innovations. Thank you very, very much for attending this.